In this video we're looking at testing two means from our hand grip strength data set. I'm not going to delete these single mean tests because I really like those graphs. SPSS doesn't do that as far as I'm aware. If anyone can find out how to do that on SPSS, that would be great. So we were testing the overall hand grip strength against some value from somebody else. Now we might be interested in having a look within our data set. Is there a difference, say, between men and women? Now we've got our sex column here where 1 is equal to females and 2 is equal to males. Now we could go through and recode that. I might just show you how to do that quickly. Code from numeric to text. Code from columns sex and store into column, and we'll just call this sex2. If the original value is 1, we want the new value to be female. I can't spell female. If the original value is 2, we want the new value to be male. And the reason I would do this is because it just makes reading the output a little bit easier if you've got labels in here instead of 1s and 2s. If you have been using SPSS in the past, you'll know that it has a variable view and it can do this in a different way. But this is how we would do it in Minitab. And you could give this a different label if you want. You'll see now it's got a T up the top because it's considering this a text column. Okay. So graphs. Let's have a quick look at a box plot. Now that we want to have a look at two groups together, a histogram is going to be a little bit more difficult to read, so we're going to do a box plot so it's easy to compare the two groups. So it's 1Y with groups, graph variable hand grip strength, and the categorical variable for grouping will be sex2. Okay. So now because I've recoded it as female and male, I've got female and male here instead of 1 and 2. And you can see here that it doesn't actually look like there's a huge amount of difference between the females and the males. We do have one guy here who was stronger than everybody else, but that might just be due to random variation. If we did the sample again, we might get a woman that was stronger than everyone else. We can't see here that all the men look on average stronger than all the women. But we can test this to see if there is a difference. So the null hypothesis that we're looking at is that there is no difference in hand grip strength between females and males in this cohort of people, which are people aged 65 or over in the UK aged care centres. I can't remember, you'll have to look at the paper. So for this particular population. So stat, basic statistics, and now we've got two options here. One says a 2-sample T and the other says a paired T, so 2T or TT. Now there's a difference in these tests in that if you have two observations on each person that go together, so if for each person we had measured their left hand grip strength with their right hand grip strength and we wanted to compare right and left, then because each set of observations went together on one person, that would be paired or matched data, and we would do what's called a paired t-test. The output will look fairly similar, it just is the mathematics behind it is a little bit different. But in this case we don't have groups that go together, we've got independent samples, we've got females are independent from the males, and so we're doing an independent samples t-test or a 2-sample t, which is here. Now it's possible that if you happen to have all your females in one column and your males in the other, you could test that here. Hopefully if you've got your data set up correctly, you've got all your samples in one column, hand grip strength, and your subscripts, which is your groups, in another. So subscripts is groups, and that will be our sex2. Now we are going to assume equal variances. If you have been watching the SPSS videos as well, I'm not quite sure why you would if you're using Minitab, but you would have seen that SPSS doesn't give you the choice to assume equal variances. It actually does the test for equal variances and it gives you both versions of the t-test all in the same output. So the t-test actually changes a little bit if the variation for one group is different from the variation for the other. If you want to test for equal variances, you can, and I think that's mentioned in the textbook, so that's a Levine's test for equal variances. The null hypothesis is that the variances are equal. If you get a large p-value, then you can accept that the variances are equal, and you would tick that. If you got a very small p-value, you would assume the variances are not equal, and so you would untick that. Graphs. We've already done a graph, so I won't worry about that. Options. Confidence level 95%, test difference 0. So you actually can test something other than that the two groups are equal. However, it still has to be very specific. So if you wanted to test that men had 5 kilogram strength advantage on women, you could test to see that the men were had 5 in here, but it would still have to be very precise, and you would have to have a reason for picking that value. Usually we just leave the test difference at 0. The alternative is that they're not equal. It's possible that you can test that one group is less than the other or greater than the other, but again, you have to have a very good reason for doing this. Usually we would just leave this at not equal. And this is called a two-sided test. You may see it written in papers that they've either done a two-sided or a one-sided test, and this is a two-sided test. Okay, so what we've got here, we've got N is the sample size, 36 females, 20 males. The mean hand grip strength for women for females is lower than it is for males. It's 8 versus 11. Standard deviations are a little bit different, but not a huge amount. So the question is this difference in mean statistically significant? Now Minitab tells us that it's testing for difference, mu male minus mu female. Its estimate for the difference is minus 2.57. You can probably ignore that for the moment. The confidence interval for the difference, probably ignore that line as well. T-test of difference equals 0. So this is where it's telling us exactly what test it's doing. So this is the null hypothesis, that the difference between the two groups is 0 versus that they're not 0. It's not written in a friendly way, that bit. So this is the null hypothesis, and the alternative is that it's not 0. The t-value is our test statistic, and this is what we're interested in here, is our p-value. We have a very high p-value, 0.26, and this tells us that there is a 26% chance of observing this data if the null hypothesis is true, and therefore we have no evidence that the null hypothesis is not true. So we have no evidence against the null hypothesis. This is a perfectly respectable chance of getting this data. So we have no reason to suspect that the true mean for males and females is not the same. However, it doesn't prove that men and women have the same average hand grip strength. All it shows is that in this particular sample, we couldn't find a difference. In general, if you're trying to detect a small difference in groups, you need a very large sample to pick it up. If there is a difference between males and females, it is probably quite small, and we couldn't detect it in this sample. So in the SPSS video, I gave an example that if we were looking, say, for the difference in throwing distance between 5-year-olds and their fathers, we might expect that the difference would be very large. And so we wouldn't need a huge sample size to pick that up. We might measure 35-year-olds and get them to throw a ball, and then get their fathers to throw the ball, and we would expect to see a large difference between the distance that a 5-year-old could throw a ball and their father could throw the ball. However, so we'd only need a small sample size to pick that up. However, as the boys get older, if we were testing 18-year-olds against their fathers, we would expect either that there's no difference at all, or that if there is a difference, it's very, very small. And actually, possibly the 18-year-olds are throwing further than their fathers by that point. So if the difference is going to be very, very small, we would need a much larger sample size to pick it up. So instead of just needing 30 or 40 or 50 people to do the test, we would suddenly need 1,000, 2,000, 3,000 to do it if we're trying to pick up a really small difference. So if you don't reject a null hypothesis, it doesn't prove that the null hypothesis is true, it just says that you don't have any evidence against it at this stage. It's possible that someone else might do another study of over 65 aged care residents in the UK. They might have a much larger sample size, and they might pick up that there is a small difference in average hand grip strength between males and females, or they might not, but we have no evidence for it at this stage.